forward. Okay, so now let's talk about families of functions, transformations, symmetry. So whenever we talk about that, we have different translations. We have the horizontal translation. In the notes, I have these formulas. So we have the horizontal translation, which means that we have y is equal to f of x minus h. And what do you recognize x minus h? We noticed that that's part of our center when we was talking about the circle. So we know this part, if h is greater than 0, then we have a translation of units to the right. So what are we talking about? We're talking about graphing a function. Okay. So if h right here is greater than 0, we're going to move this point on our graph to the right. If, however, the h is less than 0, we're going to move this particular point. And what I'm talking about point? I'm talking about the h, this here. We're going to move it on the graph to the left. Okay, so these are some good helpful notes to have. And again, it's in the PowerPoints and in the textbook. So I wanted to kind of show you right quick, use an example of what I'm talking about. Say that I have this function on the graph right here. Let's say this order pair is -5, 0. And we need to mark this point here. Let's say this point here. And you are giving f of x is equal to the absolute value of x minus 2. Well, what do I know about x minus 2? The original formula says x minus h, correct? Therefore, whatever I plugged in h, if it doesn't change this negative sign to a positive, then I know the value of h is greater than 0. Then that tells me we're going to take this function and we're going to move it to the right. The number of h, which in this case is 2. So I am going to grab this point here and I'm going to go 1, 2. I'll grab this point and go 1, 2. Same here, 1, 2. I should put a line right there. Now I got a new, well, it's not a new function, it's just it's moved. It passed some point. So that is my horizontal translation. Okay, let's talk about reflection. So whenever we're talking about reflection, it is how that function this here is on the graph. So reflection says that y equals a negative f of x is a reflection about the x-axis. And we know what the x-axis is. We know it's this line right here. So it's a reflection about it, of our function. So let's do an example right quick. Okay. So if we have this function of x is equal to x squared, and we have this other function, right? So this is going to be my main function here, right here. We have this other function, g of x is equal to negative x squared. Well, what is that? That is my reflection from the f of x. And remember, g and f is just the name of the functions. Then we know that it's going to be a reflection. So what happens? Let's apply it here, even though this is not x squared, okay, guys? But I just kind of wanted you to see what I mean by reflection. If it is a reflection about the x-axis, then that means this here literally flips over. And we get this. It's a reflection about the x-axis. Okay. Now, if it was written the absolute value of this x, right? Then we're going to get a reflection about the y-axis. So you notice the negative signs on the outside away from it, where it's just all one on the one above it. Then that means we get a reflection about the y-axis. Okay, so we just literally flip it to the side. So this is just definitions right quick. Whenever we want to talk about stretching of that function, well, stretching or shrinking of the function, we have these two things that happen. So let's take y is equal to y equals a of f of x. Okay, if a is greater than 1, that means that's a positive number right here. Okay, if it's greater than 1, then we have a stretching of the function. If a is less than 1, well, what do I know? That means a here in this function is negative number. Then that means it's going to fall between 0 and a. Well, excuse me, a is going to fall between 0 and 1. Actually, a is going to be less than 0 and less than 1, meaning it's just going to be a negative number. That's the easiest way to remember. Then we have a shrinking going on. Of our graph. All right. So let's talk about the vertical translation of this graph. If we talk about the vertical translation, then in that function, we have y is equal to f of x plus k. This means that k here, right, is going to move up or down. And I know vertical is the straight line, and we related it to the slope of our x. However, if we're going to move up or down, then we know it affects the y value. Therefore, we're talking about k. If k is greater than 0, and remember our function is got a positive there. If a k is greater than 0, then we're going to move that whole entire function that we had there at the top. We're going to move it up. We're going to bring it up, move it up. If k is less than 0, then that function there would have dropped however many numbers k is. Okay. So that's going to wrap up this section here. There is some good examples in the PowerPoint. Please look over it. Feel free to email me. I will go into depths of this in the email or next week if you need me to. There is one more example I want to do right quick, and then we'll be done with this section. Let me get me another piece of paper here. Okay. So let me do this right quick. And then, all right. So let's do it all together in one. Maybe this will help sum it all up. So if I had y is equal to a f of x minus h plus k. So this is my formula, okay? Anything changes about this will determine up, down, to the right or left, if it's stretching or shrinking, okay? So I have this function I want to work. Let's do y is equal to negative 2 x minus 3 all squared plus 4. So knowing this, we're going to look at each part, and this is what I like to do. I look at a is negative. What does it tell me? If a is negative, then I have some shrinking going on. In this one here, in with my x, the h didn't change because it's still negative. So that means that we're moving to the right, vertical, or we're moving horizontally, we're moving to the right. And then I look here, this plus sign didn't change, so I know that we're going to move up. So I go and pick out and label and list everything I can see before I start actually applying it. And then we go to our graph and we graph it, or we move the graph that's there. Okay, well, this here is seen as it's a parabola. That's what I meant to say. How do I know it's a parabola? Because it's a square here, a power of 2. So I know I get some kind of function like this. And since this is negative, I know I'm going to get it going downwards. Let's plot it. Let's plot the parabola. It looks like this. And what happens? This is my x squared. Y equals x squared. And let's apply it. When I apply it, I'm going to take this 3 here, and we're going to move it 3 places. 1, 2, 3. We're going to move it 3 places. And then I'm going to do the next thing. I want to apply the moving it upwards. So I'm going to move it up 1, 2, 3, 4. So I'm going to move it up 1, 2, 3, 4. Of course, we need to move all points, so we need to make sure we have this labeled correctly. So that means we need to move this 1, 2, 3 up 2. Move this one over 1, 2, 3 up. And then so far we got this here. So that's applying the H and the K. Now we need to do this reflection here, right? And it says a reflection about the x-axis. So we know that it's going to flip it, right? It's going to flip it all down this way. Whoops, it's going to look better when you draw it. And now we have okay. And that is the section. And there's some other ones. Definitely look at the examples of the square roots in this section. And there's another parabola. Okay, guys. So that is it of this section.